synopsis on circles. The equation of a circle with center at h comma k and radius r. The equation of circle with center at h comma k and radius r is x minus h whole square plus y minus k whole square is equal to r square. So whenever center is given and radius is given, this is the formula for finding equation of circle. Next, general equation of a circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is known as a general equation of circle whose center is minus z comma minus f. Better you remember like this. What is x coefficient 2g and y coefficient is 2f. Take half of x coefficient and change the sign. What is half of x coefficient g and what is half of y coefficient f? Change the sign, minus g minus. So remember, while finding center you remember like this. Take half of x coefficient and half of y coefficient and change the sign. That gives the center. And radius is nothing but under root g square plus f square minus c. What are the conditions for second degree equation in x and y? That is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is the second degree equation x and y. The conditions for this equation to represent x and y is coefficient of x square should be equal to coefficient of y square. That is, a should be equal to b. X square coefficient and y square coefficient should be equal. And coefficient of xy term, that is 2h, that should be 0. Which means h is equal to 0. And the third condition is g square plus f square minus ac greater than or equal to 0. So what are the three conditions for this second degree equation x and y to represent a circle? Means x square coefficient and y square coefficient should be same, that is a is equal to b, and x into y coefficient, that is 2h, that should be 0, which implies h is equal to 0. And the third condition is g square plus f square minus ac greater than or equal to 0. Next, what is the equation of a circle when diameter ends are given? Already we know the equation of circle with when center and radius is given. That is the first point which we discussed. Now instead of giving center and radius, if diameter ends are given, a and b are diameter ends. If a is x1 and b is y1, if a is x1 y1 and b is x2 y2, the equation of circle whose diameter ends are x1 y1 and x2 y2 is x minus x1 into x minus x2, this point. X minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. That is the equation of circle when diameter ends are given. Then what is the meaning of length of x-intercept and length of y-intercept? Listen here. If a circle intersects x-axis at 2 points A and B, then the distance between A and B is known as length of x-intercept, which is 2 root g square minus c. This is the formula for length of x-intercept. What is the meaning of x-intercept? If a circle intersects x-axis at 2 points A and B, distance between those two and B and those 2 points is known as length of x-intercept, which is 2 root g square minus c. Suppose if a circle intersects y-axis at 2 points, then distance between those 2 points is known as length of y-intercept, which is 2 root of f square minus c. So this is the formula for length of y-intercept and this is the formula for length of x-intercept. Okay. Next, in any circle, perpendicular bisector of chord passes through center. This is AB is a chord. What is the meaning of perpendicular bisector? Bisector means it should divide that chord into 2 equal parts, so and hence it should pass through midpoint and it should be perpendicular to it. So this is known as perpendicular bisector of chord AB, It always passes through the center of the circle. That is the meaning of that. In any circle, perpendicular bisector of chord passes through center. If AB is the chord, bisector of chord means it should pass through midpoint. Let us say M be the midpoint of AB. And if you draw a perpendicular, it is known as perpendicular bisector of chord. It always passes through center of the circle. Next, these are the notations that are followed. If the circle is represented by the letter S, if x square plus y square plus 2gx plus 2fy plus c is denoted with S, and x1, y1 is any point, x2, x1, y1 and x2, y2 are any 2 points, then what is S1? S1 is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c. Remember, S1 represents a line. S1 is equal to 0 represents a line. S is equal to 0 represents a circle. S1 is equal to 0 represents a line. This represents the equation of line. And S11 means substitute the point x1, y1 in the circle equation. Substitute x1, y1 in the circle equation. That is, in place of x, x1, in place of y, y1. Then you get S1. S1 denotes a constant. S11 denotes a constant. It is a number. Because when you substitute a point in the circle equation, then you get a number. So remember, S11 denotes a number, S1 denotes a line, S denotes a circle. Even S12 also denotes a number. S12 means x1, x2 plus y1, y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. It also denotes a constant. It's a number. S11 is a number, S12 is a number. S represents a circle, S1 represents a line. Okay. How to find position of a point with respect to a circle? Suppose if S is equal to 0 is a circle and P x1 y1 is any point in its plane. How to check whether the point lies outside the circle or inside the circle or on the circle? So to know the position of a point, you have to find S11. How to find S11? Substitute the point in the circle equation. Suppose, as I already told you, S11 represents a constant. Suppose if you get the S11 as 0, then the point lies on the circle. Suppose if you get S11 as positive, point lies outside the circle. If S11 is negative, then the point lies inside the circle. So to know whether the point lies inside or outside or on the circle, you have to find S11. Remember, point lies outside if S11 is positive. Point lies on the circle if S11 is equal to 0. Point lies inside the circle if S11 is less than 0. Here S11 less than 0. Here S11 greater than 0. Here S11 is equal to 0. Next, what are the parametric equations of the circle? For the circle x minus h whole square plus y minus k whole square is equal to r square, the parametric equations are given by x is equal to h plus r cos theta, y is equal to k plus r sin theta, where r is radius of the circle. Next, equation of a concentric circle. What is the meaning of concentric circle? Two circles having same center but different radii. Both have same center but radius will be different. Such circles are known as concentric circles. Suppose if equation of one circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0 is given circle. As I said, concentric means center should be same. What is the center for this? Minus z minus f. So center of concentric circle should also be minus z minus f. So there should not be any change in the equation till here. but radius must be different. So you have to change the constant. Instead of c, write some k. So this is the equation of concentric circle for the given circle. So if you observe those two equations, it is very clear that two concentric circle equations differ by constant. Okay. Next, what is power of a point? Power of a point with respect to the circle is nothing but S11, and it is also defined like this. Suppose if P is any point and C is the center of the circle whose radius is R, then Cp square minus R square also represents power of the point. And if you simplify Cp square minus R square, you will see that it is S11. So power of the point means either Cp square minus R square or S11, both being same. And one more way of defining the power of the point is, look at this diagram. Draw a secant line from P which intersects the circle at 2 points A and B. Then PA into PB also represents power, which is equal to S1. So power of a point is Cp square minus R square, which is S11. Even it is PA into PB, which is also equal to S1. So that is what is meant by power of a point. Next, in a cyclic quadrilateral ACBD, what is the meaning of cyclic quadrilateral? If a circle can be drawn, passing through 3 vertices, or passing through 4 vertices of a quadrilateral, that circle is known as cyclic quadrilateral. This is AB, this is CD. If P x1 y1 is point of intersection of AB and CD, then PA into PB is equal to PC into PD, and both being equal to S11. PA into PB is S11, PC into PD is also S11, therefore PA into PB is equal to PC into PD is equal to S1. Next, the equation of a circle passing through origin and making intercepts A and B on x-axis and y-axis. Look here. So this is a circle passing through origin. As I already told you, what is the meaning of x-intercept? If a circle intersects x-axis at 2 points, distance between those two is known as x-intercept, which is given as A here. If a circle intersects y-axis at 2 points, distance between those two is known as y-intercept, which is given as B. So if x-intercept and y-intercept are given, and if the circle passes through origin, then the equation of circle is x square plus y square minus ax minus by is equal to 0. Very important formula that has to be remembered. This is the equation of circle passing through origin and making x-intercept A and y-intercept B. Any circle touching x-axis. What is the condition for a circle to touch x-axis? Look here. This is a circle touching x-axis. If a circle touches x-axis, let us say center is minus g comma minus f, which means this is minus f and this is also equal to radius of the circle. Here circle is touching x-axis. If center is minus g minus f, then the horizontal distance is minus f, but vertical distance is minus f. Horizontal distance is minus g, vertical distance is minus f, which is also equal to radius. So r is equal to mod of minus f. Since r cannot be negated, put modulus. Squaring on both sides, r square is equal to f square. And we know that r square is nothing but g square plus f square minus c, which is equal to f square. You can cancel f square on both sides and you will get g square is equal to c. So what is the condition for a circle to touch x-axis means? You should remember two conditions. Radius is equal to modulus of y coordinate of center and g square is equal to c. These are very, very important conditions. So, what are the conditions for a circle to touch x-axis means? Its radius is equal to modulus of y coordinate of center, and another condition is g square is equal to c. Similarly, if a circle touches y-axis, then this will be radius, and if center is minus g minus f, then radius will be equal to mod of minus g. And if you simply simplify this, you will get f square is equal to c by squaring as we did here. So what are the two conditions that are to be remembered for a circle to touch y-axis means radius is equal to mod of x coordinate of center, and another condition is f square is equal to c. Suppose if a circle touches both the axes like this, then you have to remember r is equal to mod of minus g, and that is also equal to mod of minus f. And here we got g square is equal to c, there you got f square is equal to c, here you will get g square is equal to f square is equal to c. So if a circle touches both the axes, g square is equal to f square is equal to c, and radius is equal to mod of minus g, and that is also equal to mod of minus f. That is missing here. Okay. So these are the conditions for a circle to touch x-axis, y-axis, and both the axes. In that case, what is the circle? X square plus y square plus 2gx plus 2fy plus c. I got c as g square, so g square here. Here f square. Same points again. Instead of center minus g minus f, here a comma b, and same circle touching x-axis and y-axis. In the previous case, we considered the center as minus g minus f. Here, instead of minus g minus f, AB is given. That is the only difference. Look at this last point. The shortest and greatest distances from a point to the circle. Look here. This is center. This is P. Let us say this is A and this is B. What is the nearest point on the circle to the point P is A. A is the nearest point and B is the farthest point. So what is the shortest distance? Shortest distance of point P from the circle is nothing but PA. PA is the shortest distance. And if you observe carefully from the diagram, that PA is nothing but CP. PA means from here to here. That is nothing but CP minus R. R is the radius. Then what is the greatest distance or farthest distance of point P from the circle? PB. PB is the farthest distance. PB means from here to here, right? That PB is nothing but CP plus R. So what is the formula for shortest distance of a point from the circle means CP minus R. Farthest distance is CP plus R. Next, position of a line with respect to circle. Already we discussed position of a point with respect to circle. Now, position of a line with respect to circle means there are three different positions. The first one is the line may lie outside the circle like this, or the line may touch the circle like this, or the line may intersect the circle like this. This center, this is the radius. Let D be the perpendicular distance from center to the line. So what is D? Perpendicular distance from center to the line. If you look at the three diagrams, look at the first diagram. This is radius. From here to here is the radius, and D is perpendicular distance from center to the line. It is very clear that here R is less than D. So if radius of circle is less than perpendicular distance from center to the line, then the line completely lies outside the circle. And if you look at second diagram, here the radius and the perpendicular distance from center to the line both are equal. So what is the condition for a line to touch circle? R is equal to D. Look at third diagram where the line is intersecting the circle at 2 points. Here definitely R will be more than D. So how to find position of a point with respect to a how to find position of a line with respect to a circle mean? By finding two values R and D. R is radius of the circle, D is perpendicular distance from center of the circle to the line. If R is less than D, the line lies completely outside the circle. If R is equal to D, then the line touches the circle. If R is greater than D, then the line intersects the circle at two distinct points. Okay. Next, number of circles touching the three given lines. Suppose if three given lines are forming a triangle like this, how many circles can be drawn by touching all the three lines? This is one circle, which is known as in circle. You can draw one more circle like this by touching all the three lines, which is known as X circle. You can draw one more circle by touching all the three lines here also. Similarly, you can draw one more circle which touches all the three lines like this. So, how many circles can be drawn by touching all the three lines? If the three lines form a triangle, means altogether 4. One is in circle, the other three are X circles. Suppose out of the three lines, if two lines are parallel like this, these are the three lines out of which two are parallel. How many circles can be drawn by touching all the three lines? Means only 2. These are the only 2 circles that are possible. So we're talking about this. If two lines are parallel out of 3, the number of circles which can be drawn by touching all the three lines are 2. Suppose if all the three lines are parallel like this, you cannot draw a circle by touching all the three lines. So in that case, it is 0. 0 circles can be drawn if all the lines are parallel. If all the lines are concurrent like this, the only point circle is possible. Point circle means this is the point circle which touches all the three lines. So, if given lines form a triangle, 4 circles can be drawn by touching all the three lines. One is in circle, other 3 are X circles. If 2 lines are parallel out of 3, only 2 circles can be drawn. If 3 lines are parallel, no circle can be drawn. If all the lines are concurrent, only one circle can be drawn, which is a point circle. Okay. Next, equation of tangent to the circle at a point x1, y1 only. Suppose if s is equal to 0 is a circle and px1, y1 is a point on the circle, then this is the tangent whose equation is s1 is equal to 0. I already told you s1 represents a line. So what is the formula for equation of tangent drawn at a point px1, y1 on the circle s is equal to 0 means s1 is equal to 0. Instead of point x1, y1, if point is parametric point given, then equation of tangent to the circle is x cos theta plus y sin theta is equal to r if center is at 0, 0. Suppose if center is at minus g minus f, then what is the equation of tangent when the point is given in parametric form is x plus g into cos theta plus y plus 5 f into sin theta is equal to r, where r is the radius. Now, what is the equation of tangent to the circle in slope form? In slope form means whenever slope of tangent is given, the formula for equation of tangent is y is equal to mx plus r minus r into root of 1 plus m square if center of circle is at 0, 0. Suppose if circle center is at h comma k, in the same equation replace y with y minus k and x with x minus h. Formula will be same. Replace y with y minus k and x with x minus h. So this is the formula for equation of tangent in slope form. What is the meaning of it? Whenever slope of tangent is given, you have to use that formula. Whenever point on the circle is given, you have to use S1 is equal to 0. Okay. Next, length of chord of the circle. What is the meaning of chord? If a line intersects the circle at 2 points, distance between those two is known as length of the chord. And the formula for length of the chord is 2 into root of r square minus d square. Distance between A and B. Here in this formula, r is radius of the circle, r is radius of the circle, d is perpendicular distance from center to the line. Remember, not only remembering the formula, you need to remember what is r and what is d. R is radius of circle and d is perpendicular distance from center to that chord. Next, what is the length of the chord AB? This is the length of the chord when R and D are known. Here the length of the chord AB when parametric points are given. A is theta 1, B is theta 2. 2r into mod of sine of theta 1 minus theta 2 is the formula for length of the chord of the circle. Whenever ends of the chord are given in parametric form. Next, length of the tangent to the circle. What is the meaning of length of tangent? Let us say Px1 is any external point. From this, if you draw a tangent, let the tangent touches the circle at A. Length of the tangent means the distance from the point B where the tangent is drawn and the point where the line touches the circle. This PA distance is known as length of the tangent, which is root S1. 2 root r square minus d square is length of the chord. Root of S1 is length of the tangent. So what is the definition of length of tangent? The distance between the point B where the tangent is drawn to the point where the tangent touches the circle. PA, this PA distance is known as length of the tangent, which is root of S11. Okay. So let us discuss the next point. One of the angle bisectors of two non-parallel tangents to any circle always passes through center. What is the meaning of that? Let us say these are the two tangents, PA and PB. Angle bisector means, let us say theta be the angle between the points. Angle bisector means the line which divides this total angle into two equal parts, theta by 2, theta by 2. That always passes through center of the circle. That is the meaning of this. This angle is theta by 2, this angle is theta by 2. So this line is bisector of angle between the tangents. That bisector always passes through center. That is the meaning of it. And what is the equation of pair of tangents? Suppose if P is x1, y1. From external point, two tangents can be drawn, P and PB. The combined equation of P and PB is given by S1 square is equal to S into S1. So this is the formula for finding combined equation of pair of tangents drawn from external point to the circle. And if theta is angle between the tangents drawn from external point to the circle, then the formula for finding angle between the tangents is given by tan theta by 2 is equal to r by root S11. This is the formula for finding angle between the tangents. This is the formula for finding combined equation of pair of tangents. Okay. Tan theta by 2 is equal to r by root S1 is the formula for finding angle between the tangents drawn from external point to the circle S is equal to 0. So it is given here. If theta is angle between the tangents, tan theta by 2 is equal to r by root of S11. Next, what is chord of contact of a point? From external point, you can draw two tangents, P and PB are the tangents. The line segment joining A and B is known as chord of contact of the point. From external point P, two tangents can be drawn, right? Let A and B be the points where the tangents touches the circle. If you join these two, you will get a line. This line is known as chord of contact of the point P. And the formula for equation of chord of contact is S1 is equal to 0. Okay. Next. From external point P, two tangents A and B, two tangents P and BB are drawn. Join the points A and B. That AB is known as chord of contact. C is the center of the circle. The line joining AB is bisected by the line PC. That is, the line joining P and C divides the line AB into two equal parts. That is the meaning of this. These two lines will be same. So the line PC bisects the line segment AB. And what is area of PACB? PACB is a quadrilateral. The formula for area of PACB is R into root S11. And area of triangle PAB. Area of triangle PAB is area of triangle PAB. This is the triangle formed by two tangents drawn from P and chord of contact. R into S11 power 3 by 2 by R square plus S1. This is very important formula. And the formula for length of the chord of contact AB is 2R into root S11 by under root R square plus S1. That is length of chord AB. Okay. All these points are very important. Next, equation of director circle. What is director circle? Let P x1 y be any point from which tangents are drawn. If angle between the tangents is 90 degrees, then the locus of P, locus of this point, what is this point? It is intersection point of perpendicular tangents. You can draw a diagram like this. Draw two perpendicular tangents. The locus of point of intersection of perpendicular tangents. P is the point of intersection of perpendicular tangents. The locus of such point is known as director circle. If given circle is x square plus y square is equal to a square, then locus of P is also a circle which is concentric with the given circle like this, and its equation is x square plus y square is equal to 2a square. So what is the definition of director circle? It is a locus of point of intersection of perpendicular tangents drawn to a circle. If given circle is x square plus y square is equal to a square, its director circle is x square plus y square is equal to a square, which is concentric with the given circle. Both the circles are concentric. Next, what is the equation of chord of a circle when midpoint is given? S1 is equal to S11 and length of the chord is 2 root mod S1. So when we have to use this for finding equation of chord, when midpoint of chord is given. So equation of chord whose midpoint is x1 by 1 is S1 is equal to S11 and length of the chord is 2 root mod S1. Already you know the length of the chord formula is 2 root R square minus D square. Then this is also the length of the chord only. When we have to use this? Whenever midpoint of chord is given. And this formula can be used whenever equation of circle is given. Okay. Next, in any triangle, these are very important shortcuts which are useful for solving questions. The image of orthocenter with respect to any side lies on the circumcircle of the triangle. Suppose if O is orthocenter, image of the point O with respect to the side BC, which is O dash, it lies on the circumcircle of the triangle. Similarly, the image of vertex A of triangle ABC with respect to internal bisectors of angles B and C. So these are the bisectors of angles B and C. Image of A, vertex A, with respect to the internal bisectors of angle B and C lies on the line BC. These 2 points are very important. Next. If the lines a1x plus b1y plus c10 and a2x plus b2y plus c20, these are the 2 lines. Let us say this is one line. Then let us say this is another line. So first line intersects x-axis at A and y-axis at B. Second line intersects at C and D. So those 2 lines those 2 lines are intersecting coordinate axis at 2 points each. Now the condition for these 4 points to be concyclic. What is the meaning of concyclic? Points should lie on same circle. The condition for these points A, B, C, D to be concyclic is A1, A2 is equal to B1, B2. That is the condition for all these 4 points to lie on same circle is A1, A2 is equal to B1, B2. Next, through 2 points A and B, so many circles can be drawn passing through 2 points. Among those circles, the circle with AB as diameter will be the least circle. So what is a circle drawn passing through 2 points will be least? It is a circle when those 2 points are diameter ends. Next, equation of chord joining 2 parametric points on the circle. X plus z cos of alpha plus beta by 2 plus y plus f sin of alpha plus beta by 2 is equal to r cos alpha minus beta by 2. So that is the formula for equation of chord when 2 points are given in parametric form. Next, normal always passes through center of the circle. Let us say P is any point. This is tangent at P. Normal is nothing but a line perpendicular to the tangent. That normal always passes through center of the circle. Number of normals through a point to circle is 1. Number of normals drawn from center of a circle to the same circle are infinity. And what is the length of normal chord? Just now I told you normal passes through center. So length of the normal is nothing but diameter of the circle. So length of normal is nothing but diameter of the circle. Next, the equation of polar of a point is S1 is equal to 0. If P lies outside the circle, if point lies outside the circle, then its polar and chord of contact both are same. If P lies on the circle, polar is nothing but tangent. If P lies inside the circle, its polar lies completely outside the circle like this. If P lies outside, polar and chord of contact will be same, which will be like this. If P is on the circle, polar becomes tangent. If P is inside the circle, polar lies completely outside. Next, the polar of center of a circle with respect to same circle doesn't exist. Next, polar. This is polar of P, right? Polar of P. Polar of P is always perpendicular to the line joining center to the point. These two are always perpendicular. This point is very important. Polar of a point P is always perpendicular to the line joining center and P. And polars of collinear points are concurrent. What does it mean? If points are collinear, suppose if A, B, C are three collinear points. For every point there will be a polar, right? Polar of A, polar of B, polar of C are concurrent. So if points are collinear, their polars are concurrent. That is the meaning of this point. If points are collinear, then polars of that point with respect to same circle are concurrent. Next, these are the formulas for finding pole of a line. Pole of Lx plus My plus N is equal to 0 is, with respect to a circle whose center is at origin, is minus r square L by N minus r square by N. Suppose if the circle equation is x square plus y square plus 2gx plus 2fy plus c0, then this is the formula for finding pole. And the condition for 2 points to be conjugate is s12 is equal to 0. And if circle equation is x square plus y square is equal to r square, this is the condition for two lines to be conjugate. And this is the condition for two lines to be conjugate if circle center is at minus z minus f. If circle center is at 0, 0, the condition for the lines to be conjugate is r square into L1 L2 plus M1 M2 is equal to N1 N2. If circle center is at minus z minus f, the condition for two lines to be conjugate is r square into L1 L2 plus M1 M2 is equal to L1g plus M1 M minus N1 into L2g plus M2f minus N2, where r is radius of the circle. So these are the conditions for conjugate. S12 is equal to 0 is the condition for conjugate points, and these are the conditions for conjugate lines. Next, what are inverse points? 2 points P and Q are said to be inverse points with respect to circle if three conditions are satisfied. First condition is center of the circle P and Q should lie on same line, which means these 3 points should be collinear. 2 points P and Q are said to be inverse points with respect to a circle if three conditions are satisfied. The first condition is CPQ are collinear, that is all the three should lie on same line. And second condition is P and Q should lie on same side of the center. Look at this diagram. P and Q should lie on same side of the center. That is, Q cannot be outside this line. Okay, both P and Q should lie on same side. And the third condition is CP into CQ should be equal to R square. So these are the three conditions for 2 points P and Q to be inverse points with respect to a circle. Next, how to find inverse point? Here Q is said to be inverse point of P. Q is nothing but foot of, this is polar of P. This line is polar of P. Q is said to be inverse point of so how to get Q? Look at the diagram. Q is clearly the foot of perpendicular drawn from P onto the polar of P, or Q is foot of perpendicular drawn from center onto the polar of P. So the inverse point is foot of perpendicular drawn from P or from center to the polar of P. Next, relative positions of two circles. That is, if two circles are given, how to check whether they are intersecting or whether they are touching externally or internally means. For that we have to find two values. One is distance between centers and radii of the two circles. Look at this diagram. If distance between centers is more than r1 plus r2, then one circle lies completely outside the other. And in this case, altogether 4 common tangents can be drawn. 2 are direct and 2 are transverse. Suppose if C1, C2 is equal to R1 plus R2, then the two circles touch each other externally. And in this case, 2 direct common tangents and 1 transverse common tangent can be drawn. and the point of contact P. This is a point of contact P. It divides the line joining centers in the ratio R1 is to R2 internal. P is a point which divides the line joining centers in the ratio R1 is to R2 internally. Here number of common tangents that can be drawn are 3, 2 direct and 1 transverse. But this is a condition for two circles to intersect each other. Mod of R1 minus R2 less than C1 C2 less than R1 plus R2. In this case only two common tangents can be drawn and both are direct common tangents. If C1 C2 is equal to mod of R1 minus R2, then two circles touch each other internally and the point of contact Q divides the line joining centers in the ratio R1 is to R2 external. Clearly Q is outside the two circles. So Q divides the line joining centers externally. If C1 C2 is less than mod of R1 as R2, then one circle lies completely inside the other. In this case, no common tangents can be drawn. Next, centers of similitudes. Look here. This is direct common tangent. This is also direct common tangent. The point of intersection of direct common tangents is known as external center of similitude. And it is a point which divides the line joining centers in the ratio R1 is to R2 external. Q is a point which divides the line joining centers in the ratio R1 is to R2 externally. Next. This is one transverse common tangent. This is another transverse common tangent. The intersection point of transverse common tangents is known as internal center of similitude, and it is a point which divides the line joining centers in the ratio R1 is to R2 internally. Internal center of similitude divides line joining centers in the ratio R1 is to R2 internally. External center of similitude is a point which divides the line joining centers in the ratio R1 is to R2 external. Next, what is length of direct common tangent? Under root d square minus R1 minus R2 whole square. And length of transverse common tangent is under root d square minus R1 plus R2 whole square. Here, what is the distance between the centers? As I already told you, in any formula, you need to know what are the variables present in that. Here, d is distance between centers. R1, R2 are the radii of the two circles. Okay. Next, the equation of family of circles passing through point of intersection of a circle and a line. Let us say S is equal to 0 is a circle and L is equal to 0 is a line. Let us say both are intersecting at 2 points A and B. Now, through these 2 points A and B, we can draw number of circles like this. We can draw so many circles like this, and the equation of that circle is S plus lambda L is equal to 0, where lambda is a parameter. By giving different values for lambda, we get different circles, but every circle passes through same 2 points A and B. So those are known as family of circles. So what is the equation of family of circles passing through intersection point of given circle and given line means S plus lambda L is equal to 0. And what is angle between two circles? Angle between two circles is nothing but angle between their tangents drawn to the two circles at their intersection points. Let us say P is one of the intersection points. This is the tangent drawn at P to the first circle. This is the tangent drawn to the second circle at the same point. If theta is angle between those two tangents, that theta itself is known as angle between the two circles. So what is the definition of angle between two circles? It is nothing but angle between the tangents drawn to the circles at their common intersection point. And the formula for finding angle between the tangents is this. Cos theta is equal to d square minus r1 square minus r2 square by 2 r1 r2. D is distance between the centers and r1 r2 are the radii of the two circles. And when we say that two circles are intersecting orthogonally, then angle between them is 90 degrees. So two circles are orthogonally intersecting means angle between them is 90. If angle is 90, cos 90 becomes 0, and hence d square minus r1 square minus r2 square becomes 0, or d square is equal to r1 square plus r2 square. So this is a condition for two circles to intersect orthogonally. That is a condition given here. And the same condition can be written like this if circle equations are given in general form: x square plus y square plus 2gx plus 2fy plus c, and x square plus y square plus 2g dash x, this is g dash x, plus 2f dash y plus c dash is equal to 0. What is the condition for two circles to intersect orthogonally means 2g dash plus 2f dash is equal to c plus c dash. So these are the conditions for two circles to intersect orthogonally. Next, if two circles S is equal to 0 and S dash is equal to 0 intersect each other at 2 points A and B, if we join those 2 points, you will get a line. This line is a chord for both the circles. This line AB is a chord for both the circles, and hence it is known as common chord. What is the formula for finding equation of common chord? Means S minus S dash is equal to 0. So if you subtract the two circle equations, then you will get a line equation. That line is known as common chord. And formula for finding length of common chord is 2 r1 r2 sin theta by under root r1 square plus r2 square plus 2 r1 r2 cos theta. Here theta is angle between the circles. We know the formula for angle between the circles already. So by using that formula, you can find theta, and if you substitute here, you will get length of the common chord of the two circles to r1 r2. This is r1 r2, this is r1 square. Suppose if two circles are intersecting orthogonally, theta is 90, then what is the length of the common chord? In this formula, put theta 90, then sin theta, sin 90 becomes 1, cos 90 becomes 0, and hence 2 r1 r2 by under root r1 square plus r2 square is the length of the common chord when the two circles are intersecting orthogonally. Next, if A and B are conjugate points with respect to circle S is equal to 0, these are very, very important shortcuts or important points to be remembered. If A and B are conjugate points with respect to a circle S is equal to 0, then the circle having AB as diameter cuts a given circle orthogonally. And when we say that one circle bisects the circumference of the other circle, look here, S is equal to 0 is one circle, S dash is equal to 0 is another circle. This circle S dash is equal to 0 bisects the circle S is equal to 0 if common chord, this is common chord, AB is common chord. Now this common chord is diameter of the first circle. So when we say that a circle S dash is equal to 0 bisects the circle S is equal to 0, if common chord of the circles is the diameter of the first circle. So diagram will be like this. Then what is the definition of radical axis of two circles? Radical axis of two circles is nothing but the locus of a point whose power with respect to both the circles are equal. So the definition of radical axis is locus of a point whose power with respect to both the circles are equal is known as radical axis. For example, if these are the two circles, S0, S dash, and there is a point P like this. The power of this point P with respect to the first circle and with respect to second circle are equal. We have so many points whose power with respect to both the circles are equal. If you join all those, you will get a line that is known as locus of the point P, which is nothing but radical axis. The lengths of tangents drawn from P. P is a point on radical axis. So these are the lengths of the tangents. PA is length of tangent from P to the first circle. PB is length of the tangent. And you will see that P and PB are equal. So lengths of the tangents drawn from a point on radical axis to the two given circles are equal. PA is equal to PB. Now these are the properties of radical axis. The locus of center of a circle which cuts two given circles orthogonally is the radical axis of the two given circles. Suppose if these are the two given circles and this is a circle which is intersecting two given circles orthogonally. S is equal to 0, S dash is equal to 0 are two circles. And this is the circle which cuts two circles orthogonally. Such circle center lies on radical axis. So the locus of center of a circle which cuts two given circles orthogonal is nothing but radical axis. And radical axis of two circles is always perpendicular to line joining their centers. This is the radical axis. This is the line joining centers. These two are always perpendicular. And radical axis bisects each of the common tangents. This is the common tangent, right? This radical axis bisects the common tangent. That is, radical axis divides common tangent into two equal parts. And if two circles intersect each other, their common chord is nothing but radical axis. This is the common chord which is nothing but radical axis. If two circles touch each other like this is known as common tangent. That itself is radical axis. So if two circles intersect each other, common chord is radical axis. If two circles touch each other, common tangent is radical axis. For concentric circles, radical axis doesn't exist. Suppose if two circles having same center like this, radical axis doesn't exist for this. These are the points already discussed. The lengths of the tangents drawn from radical center to the two circles are equal. Now, if there are three circles like this, the circle which cuts three circles orthogonally, the center of that circle is nothing but radical center of the given circles. What is radical center? Point of intersection of radical axis. So this circle, this bigger circle is intersecting three circles orthogonally. Such circle center is nothing but radical center. And with the radical center as center and this length of the tangent as radius, if we draw a circle, that circle cuts the three circles orthogonally. This is a converse point of the previous one. With radical center as center and length of the tangent as radius, if a circle is drawn, that circle cuts all the three given circles orthogonally. That is the meaning of this point. And all these points are to be remembered. These are the synopsis points which are to be remembered. The radical center of three circles described on three sides of a triangle as diameters is orthocenter. If ABC are centers of three circles which cuts each other orthogonally, then radical center of the three circles is orthocenter of triangle ABC. If ABC are centers of three circles which touch each other externally, then the radical center is nothing but incenter. So all these points you need to remember as a standard results. Proofs are beyond the scope.